Okay, so this is the second 3x3 matrix on the worksheet, and we're going to try to find the inverse of this matrix B if it exists. Okay, so to find that inverse, I basically augment the matrix B with the identity matrix, and we try to do row reduction. Okay, so I want to eliminate, so here I have a 2, non-zero, that's good. I want to eliminate the -1 here and there. Okay, so to do that, I'm going to, let's see, so for row 2, I want to add, and I'm not going to be particular about subtracting a multiple of one row from another. I'm just going to say that with row 2, I want to add a half of row 1 and put that in row 2. And then I'm going to do the same thing for row 3. So for row 3, I'm going to add a half of row 1 and put that in row 3. Okay. Now, I'll make a comment that some of you may have seen some of this before, and there may be some tricks that you can do to avoid dealing with fractions. Okay, and that's fine for the homework. However, when I do the row reduction, I'm just going to follow one path and not try to do any tricks. Okay, so in keeping with doing these row operations, our first row stays the same, and then the second row changes too. So this guy's a 0. So I'm adding a half of -1, or minus a half from 2. That's 3 halves. Okay, -1, and then minus a half is -3 halves. And then I'm adding a half to 0. So it puts a half there. And then the other two entries don't change. And then down for this third row, 0 here, okay? And then I'm subtracting a half from -1, so that will give me a -3 halves. And then with this 2, I'm subtracting a half, and I get 3 halves. Okay. And then I do a 0 plus a half of 1, or 1 half. And then these two zeros there mean that I don't do anything to those entries of row 3. Okay? So here I've eliminated the first column. Okay, and now I move on to the second column, and I look at the second entry here, this 3, 2, and that's non-zero, so I try to eliminate below it. Okay, and here you can see that, well, 3 halves and then a -3 halves means all I need to do is do row 3 plus row 2 and put that in row 3. So if we do that, first row stays the same, second row stays the same, and now this third row is 0, 0, 0, and 1, 1, 1. All right, and now this is the first case where we've gotten zeros here. All right, and that means that this matrix is not invertible. Okay, so we'd like to have 3 non-zero entries along this diagonal. We do not. This 0 here, and all 3 of these zeros here mean that B is not invertible. And as I mentioned previously, it means that another term we use is that B is singular.